Alright, we're going to talk about transformers. In air conditioning, we use step-down transformers. To make a step-up transformer, well, primarily for control purposes, we're going to use a step-down transformer. This is the symbol for a transformer. You have a winding, a core, a second set of windings. The set of windings that you apply power to is called your primary. You're going to get a voltage out of your secondary. For air conditioning, your secondary voltage is 24 volts AC. Now in your primary, you could apply 110 volts, 120, 208, 230 volts, but make sure you have the right transformer. But what we're going to talk about here is what we call a multi-tap transformer. So first of all, my secondary wires here are green and red, and I know that because it says it on top of the transformer. Now, the reason I have so many wires here, one of them is a white wire. It's going to hook up no matter what. Then we have a black wire. You then have a red wire and an orange wire. Okay? If you wanted to hook this system up to 110 volts, you cap off your orange and your red, and you hook up your 110 between white and black. If you want to use 208, you cap off your black and your orange, hook up white and red. If it was 230, cap off red and black, hook up white and orange. So no matter what, you're going to use white. Whatever you don't use, you cap them off. Do not hook them together. Cap them off. If you hook them together, you're going to short it out. But no matter what voltage you hook up, you're always going to come out with 24 volts. Checking this is very easy. If you want to check it with power applied to it, you simply check power going in and power coming out of it. If you have power going in, you don't have power coming out of it, it's bad. It's important to know which side is burnt out. If it's your secondary side burnt out, you have a load, a contactor, a relay. One of your wires could be rubbing together. I've seen them go to the condensing unit, rub together, and short out. Something down here that this feeds is shorted out. So let's just check it. We're going to start with the secondary first. We're looking for resistance. That secondary is going to be a very, very low resistance. So between green, we have 1.2 ohms. Very low resistance. But here again, it's not a load. That is actually going to be supplying the rest of your system. Now, to check the primary side, we're going to clip on this white wire here, and I'm actually never going to move that one. I'm going to check white to black, white to red, white to orange. And as I go, the resistance should increase. White to black. 19.9, let's just say 20 ohms. Leaving it on white, and then I'm going to move to red. So this black is 110, will go up in voltage. Here's 208. 51 ohms. Then I'm going to leave it on white again, come off of red. Black was 110, this was 208. Here's 230. 71 ohms. Well, it jumped down on me, I apologize. 63 ohms. So you can see between white and black was only 20 ohms. This little section right here. Then white and red, we went up 30 more ohms. Then white to orange, we went up another 12 ohms. So let's just say 50 plus 20, so that's 114, 130 total. So we went from white to orange, we should get all of them. We could break it down between red and orange. So if we had 51 here, that's an extra 14, so let's try red and orange. 13 ohms. So you can see how we can pick that up. If you had from here to here 51, and then from here to here 63, you picked up another 12, 13 ohms, you can ohm them out individually and get it. But it's very simple. My caution here again, if you check from green to red or whatever your color is on yours, and this reads an open line, OL, that means your secondary was burnt out. If your secondary is burnt out, something down here, and all it feeds there goes to your this goes to your thermostat, and then your thermostat feeds your blower relay on your contactor. Your blower relay is shorted out, your contactor is shorted out, one or the other, or you have some wires going to the condenser unit. I've seen dogs chew them out, rats chew them out, squirrels. Something is shorted that keeps blowing your transformer. So when you put in a new transformer and your secondary is burned, what I like to do is, before I hook up my red wire, get my amp meter ready, clip it over a wire here, and just touch the red wire where it's supposed to go, and see if your amp draw shoots up. A lot of transformers are only rated, they have a fuse on that goes off at 3 amps. So if you hook it up, you pull in 5, 6, 7, 8 amps, something's wrong. Very, very easy to check.